Hi there, amazing students, amazing people, and all the lovers of chemistry out there. I'm super excited to be here with you on this space where we get to solve this equation on this series thus far. Where we've been dealing with the concept of redox reactions. So here we have this question on the screen, and we have been asked to balance it in the basic medium. So you've seen the rules, you've seen the step-by-step procedure that it takes to balance a redox reaction in the basic medium. So let's apply them and see what we will get. So the first step says to change this or to break this down into the oxidation and the reduction half. So for the first half, we have Al giving us AlOH 4 minus. And for the second half, we have NO₃ minus, giving us NH₃. Now, at this point, what we want to do is to identify which part is the oxidation part and which part is the reduction part. So to do that, we need to find the oxidation numbers of the elements in this in both half reactions, and then we'll determine which part is being oxidized and which part is being reduced. So over here, you can see aluminum is in its pure state, which means that its oxidation number is 0 or it is neutral. But over here, we don't know the oxidation number of aluminum, so let's call it X, since it's in a compound. And then this becomes X plus, we have oxygen over here, which means, and that tells us that oxygen has the oxidation number of -2 in compounds, plus, over here we have hydrogen, and hydrogen has the oxidation number of 1 in compounds. So we close the bracket. This subscript of 4 indicates that everything in the bracket is multiplied by 4, and that gives us the overall charge, which is -1, or it is equal to the overall charge, and in this case the overall charge is -1. So therefore we have X plus -2 plus 1 gives us -1 times 4 equal to -1. So now we have X minus 4 equal to -1. X is now equal to -1 plus 4, which is equal to plus 3. So the oxidation number of aluminium moves from 0 to plus 3. That tells us that oxidation has occurred. Oxidation has occurred because the oxidation number increases. So therefore, we name this our oxidation half. I just shorten it by saying OX. Now let's check out for the other equation. Now for the other equation, we have NO₃ minus, giving us NH₃. Let's find the oxidation number of nitrogen in both compounds. So in this case, we do not know the oxidation number of nitrogen, so we call it X plus, over here we have oxygen, and the oxidation number of oxygen in compounds is -2, multiplied by the number of atoms we have, which is 3. This is equal to the overall charge of the compound, which is -1. So we have X plus -2 times 3 gives us -6. This is equal to -1. And then we have X minus 6 equal to -1. X is equal to -1 plus 6. X is equal to plus 5. So the oxidation number of nitrogen in this compound is plus 5. Let's find out the oxidation number of nitrogen in this compound. So we have NH₃. The oxidation number of nitrogen here is unknown, so we'll call it X plus. Hydrogen here has the oxidation number of +1 in compounds times the number of atoms which we have, and in this case that is 3. This is equal to the entire charge, which is 0. So we have X plus 1 times 3 gives us 3. This is equal to 0. So X plus 3 is equal to 0. X is equal to -3. So the oxidation number of nitrogen here is -3. So the oxidation number moves from +5 to -3, which shows that it has reduced. So automatically this becomes our reduction half. So now that we have identified our oxidation half and our reduction half, the next step says balance every other atom apart from hydrogen and oxygen. So let's do that very quickly and see what we'll get. So now, apart from oxygen and hydrogen, the only other atom we have in the first half equation is aluminium. And if you check very well, The only number of aluminium here is 1, and over here aluminium is also 1 atom. So that rule has been obeyed by this equation. For the second half, we have NO3 minus, giving us NH3. The only other atom we have apart from oxygen and hydrogen is nitrogen, which in this case is balanced because we have 1 apiece, which is 1 on both sides. So this step has been carried out. The next thing says we are to balance oxygen by adding water molecules and balance hydrogen by adding hydrogen ions. So let's do that very quickly. Now for the first equation, we have Al giving us AlOH4 minus. Now, on this equation, we have oxygen on the right-hand side. How many atoms of oxygen do we have? Over here, there is just 1 atom of oxygen times the subscript of 4, which affects everything in this bracket. So we have 1 times 4, which gives us 4 atoms of oxygen. That tells us that we need to add 4 atoms of, or 4 molecules of water to the left-hand side to balance oxygen. So now we've added the 4 molecules of water. Now, if you can check now, how many atoms of hydrogen do we have on the left-hand side? There's a subscript or a coefficient of 4 here and a subscript of 2 here that affects this hydrogen. 4 times 2 gives us 8 atoms of hydrogen on the left-hand side. On the right-hand side, you can see there is also an atom of hydrogen here, and it has a subscript of 4. And that gives us 4 hydrogen atoms on the right-hand side. So that tells us that we need to add 4 hydrogen ions to the right-hand side to balance hydrogen. So therefore, we now have the new equation, which is Al plus 4H2O, giving us AlOH 4 minus. So plus 4H plus. So now that we have added oxygen and water molecules to balance oxygen and hydrogen ions to balance hydrogen, let's do the same for the second equation. For the second equation, what we have is NO3 minus, giving us NH3. So now let's start by balancing oxygen using water molecules. On the left hand side, you can see there are 3 atoms of oxygen. On the right hand side, there is 0 atoms of oxygen. So that tells us that on the right hand side, we need to add 3 molecules of water. Now that we've added 3 molecules of water, we need to find out how many hydrogen atoms are on both sides so we can balance it. On the right hand side, you can see hydrogen is here and it has a subscript of 3. On the right hand side, we have 3 atoms of hydrogen plus. Over here, we also have hydrogen and it has a coefficient of 3 and a subscript of 2. That gives us 3 times 2, which is equal to 6. So we have 3 plus 6, that is 9 hydrogen atoms. So that tells us that we need to add 9 hydrogen ions to the left side in order to balance hydrogen atoms. I'm sure you can see how everything is playing out. So for the first equation now, we have NO3 minus plus 9H plus, giving us NH3 plus 3H2O. And then for the second equation, we have Al plus 4H2O, giving us AlOH 4 minus plus 4H plus. Now that we've done that, the next rule or the next step says to balance charges by adding electrons to the appropriate side. So let's do that very quickly and see how that plays out. So now the next step says balance charges by adding electrons. How do we do that? For the first half, we have NO3 minus plus 9H plus, giving us NH3 plus 3H2O. To balance charges, we simply need to find out the total charge on the left side and find out the total charge on the right side, and then add a sufficient number of electrons, which in this case we denote by writing E minus, to the side that is more positive so that the charges can balance. On the left hand side, you can see there is a minus sign over here, which indicates a charge of -1. Plus, over here you can see there is a sign plus here, which indicates a charge of +1 times the number of atoms that own that charge, which is 9 um, atoms of hydrogen ions. So the total charge on the left hand side now becomes -1 plus 9, which is 8, or plus 8. On the right hand side, however, you can see there is no plus or minus sign. So this place is basically neutral, or the charge is 0. So we have 0 on the right hand and 8 on the left hand side. So to make both sides equal, it means we need to add 8 electrons to the left hand side so that this positive charge can be neutralized by these electrons to make it to be equal to 0. So therefore, the new equation now becomes NO₃ minus plus 9H plus 8 electrons that we just added, 8E minus NH₃ plus 3H2O. Now that we have done that, the second equation now, we have Al plus 4H2O giving us AlOH4 minus plus 4H plus. Now on the left hand side, you can see there are no plus or minus signs, which means that this left hand side is neutral. On the right hand side, let's check it out. You can see a minus sign here, which indicates a charge of -1, plus over here you can see a plus sign, which indicates a charge of +1, times the number of atoms that own that charge, which is 4. So on the right hand side, we have -1 plus 1 times 4 gives us 4. This becomes +3. So on the left hand side, we have 0, and on the right hand side, we have +3. So that means we need to add 3 electrons to the right hand side to make the charges to be equal on both sides. So the next equation now becomes, or the final equation after adding charges now becomes Al plus 4H2O giving us AlOH4 minus plus 4H plus 3E minus. Now we've added the charges and we've added the electrons to balance the charges. The next rule says make the electrons equal in both halves by multiplying appropriately. So let's see how that can be done. So at this point now, we want to balance electrons in both reactions. In the first reaction, you can see we have 8 electrons. The second reaction, we have 3 electrons. How do we make the two of them to be equal? We can do that by simply multiplying this equation by 3 and multiplying this equation by 8. That way, we're going to have 24 electrons in both equations. So let's do that very quickly. Multiplying now, what we have is 3NO₃ minus plus 3 multiplied by 9 here is 27H plus 8 multiplied by 3, we have 24E minus. Now we have 3NH₃ plus 3 multiplied by 3H2O here. Now we have 9H2O. We've multiplied this equation by 3. Now let's multiply the second equation by 8. Now we have 8Al plus 8 multiplied by 4. 8 multiplied by 4 is 32 molecules of water, giving us 8AlOH4 minus plus 8 multiplied by 4H plus, that is 32H plus 24E minus. Now that we have the same number of electrons in both equations, they can cancel out. So this one can cancel this one. Both of them goes. So now what we have as our equations, new equations now become 3NO₃ minus plus 27H plus, giving us 3NH₃ plus 9H2O. And then the second equation now becomes 8Al plus 32H2O, giving us 8AlOH4 minus plus 32H plus. So now that we have our two new equations, the next rule says that after you have balanced electrons in both halves, now you add both equations together and cancel out whatever is the same on both sides. Let me show you how to do that very quickly. All right, now, so at this stage, what we want to do is to add both equations together. So in both equations, everything on the left side will go together. So let's add the left side together. On the left side, we have 3NO₃ minus plus 27H plus 8Al plus 32H2O. And then everything on the right hand side in both equations will go together. So on the right hand side, we have 3NH3 plus 9H2O plus 8AlOH4 minus plus 32H plus. So you can see we've added both equations together. Now at this point, we are going to cancel out anything that appears on both sides that are identical. What do we mean? On the left hand side, you can see we have 27H plus ions. And on the right hand side, you can see we have 32H plus ions. So between 27 and 32, which one is greater? Of course, 32 is greater. So we just eliminate the 27 ions over here and take them out of 32. When you remove 27 from 32, what you will have remaining is 5H plus ions. So what we have on the right hand side now is 5H plus ions, and we've taken out the 27H plus ions. Now let's check. Over here you can see we have water molecules 32. And over here you can see we have water molecules 9. So if we take out these 9 water molecules from 32, how many are we going to have left? If we say 32 minus 9. 32 minus 9 is going to give us 23. So we have 23 water molecules. 23 water molecules at this point. So now our new equation now becomes 3NO₃ minus plus 8Al plus 23H2O, or 23 water molecules, giving us 3NH3 plus 8AlOH4 minus plus 5H plus. Now that we have done this, the next rule says that wherever you have H plus ions, add an equal number of OH minus to both sides to neutralize it. So let's do that very quickly. Now at this point, you can see we have some H plus ions on the right hand side, 5H plus ions, which tells us that we need to add 5 OH minus to both the right hand side and add the same 5 OH minus to the left hand side. So when we do that, what we're going to end up having as our new equation will now become 3NO₃ minus plus 8Al plus 23H2O plus 5OH, the 5OH ions that we added, then giving us 3NH3 plus 8AlOH4 minus plus 5H plus 5OH minus. Now, as a final rule, it is said that wherever you have H plus and OH minus to both in the same side, add them together to give you H2O. Now on this right hand side, you can see we have 5H plus and we have 5OH minus. which tells us that 5H plus added to 5OH minus will give us 5 molecules of water. So when we do that, our new equation now becomes 3NO3 minus plus 8Al plus 23H2O plus 5OH minus will now give us 3NH3 plus 8Al OH4 minus plus 5H2O. So now that we have this equation, this is the equation that we have. So at this point now, I want you to watch. We have 23 water molecules on the left side, and over here we have 5 water molecules. We can still do some math by cancelling out. If we take 5 molecules out of here and take 5 molecules out of here, what we have left will now be 18 water molecules. 18 water molecules. So therefore, this is what our final equation will now become. So now that we've taken out the water molecules from both sides, what we're going to have is 3NO3 minus plus 8Al plus 18H2O plus 5OH minus, giving us 3NH3 plus 8AlOH4 minus. And that will be, because we've taken out this 5H2O, we're not writing anything again. So at this point, this is our final equation. We've taken all the steps. We've taken every step that can be taken. Now, at this point, we've gotten our final balanced equation, but let's do a little check. Is everything balanced? Are charges balanced and our atoms balanced? Let's check it out. On the left-hand side, you can see there is a charge of minus here, which indicates a charge of -1. And there is a coefficient of 3 here, which indicates a charge of -1 times 3. And over here, you can see we have a charge of minus. So this becomes plus -1. And then we have 5, the coefficient of 5 here, which is times 5. So the total charge here becomes -3 plus -1 times 5 gives us -5. Total charge here becomes -3 minus 5, which is equal to -8 on the left hand side. Now let's check out the right hand side and see. Over here there is no charge, so this is 0. We have 0 plus. Over here you can see a charge of minus, which indicates a charge of -1 times a coefficient of 8. So we have 0 plus -8. So all this is equal to -8. So the charges are balanced. The charges are balanced. Now we want to know if the atoms are balanced as well. So let's check it out. So at this point now we have determined the charge to be -8 on both sides. So let's see if the atoms are also balanced. The first atom or element that we have is nitrogen. On the left hand side, you can see we have 3 atoms of nitrogen over here because of this coefficient of 3 that affects this entire compound. So we have 3 on the left side. On the right side, you can also see we have nitrogen over here, and it has a coefficient of 3. So we have 3 on both sides. Nitrogen is balanced. The next element we have is oxygen. Over here, you can see oxygen. It has a subscript of 3 and a coefficient of 3 as well. That becomes 9, because 3 times 3 is 9. Do we have any other oxygen molecules? Yes, we do. Oxygen is also over here. That is 1 atom of oxygen, and it has a coefficient of 18. So 9 plus 18 plus. Over here, we also have oxygen. It has a coefficient of 5. So we have 9 plus 18 plus 5. 9 plus 18 plus 5 will give us 9 plus 5, first of all, will give us 14. So we have 18 plus 14. 8 plus 4 gives us 12. 2 carry 1. 1 plus 1, 2 plus 1, 3. So we have 32 atoms of oxygen on the left side. How about on the right side? Let's check it out. Over here, you can see we have oxygen. Oxygen has a subscript of 4 over here. So we have 4 times a coefficient of 8 over here. 4 times 8 is straight up 32. So we have 32 on both sides of the equation. So oxygen is also balanced. The next atom or element that we have is aluminium. How many atoms of aluminium do we have on the left hand side? There are 8 atoms of aluminium over here if you check it out. 8 atoms of aluminium. 8 atoms of aluminium on the left hand side. And then on the right hand side, you can see we also have 8 atoms of aluminium here because of this coefficient of 8. So aluminium is also balanced. And then finally, we have hydrogen. How many atoms of hydrogen do we have on the left hand side? We have hydrogen over here. Hydrogen has a subscript of 2 and a coefficient of 18. That gives us 18 times 2 plus, over here we also have hydrogen. And hydrogen has this coefficient of 5. So plus 5. 18 times 2 is 36. 36 plus 5 gives us 41. 41. How many atoms of hydrogen do we have on the right hand side now? We have hydrogen over here. Hydrogen has a subscript of 3 and a coefficient of 3. So that becomes 3 times 3, which is equal to 9 plus, over here we also have hydrogen. You can see hydrogen is over here. It has a subscript of 4 because it's contained inside this bracket, and that subscript affects everything in the bracket. So it has a subscript of 4 times a coefficient of 8. 4 times 8 gives us 32. So we have 32 plus 9. 32 plus 9 is 41. So hydrogen is 41 on both the left hand side and on the right hand side. So this equation is balanced in terms of charges and in terms of atoms as well. So at this point, we have fully balanced this equation in the basic medium. So let's write out the full equation again. So at this point, my friends, we've come to the end of this video where we have our final balanced equation in the basic medium. Everything is balanced. The charges are balanced, minus 8 on both sides, and the atoms are balanced, each and every single one of them. If you stuck around till this point, I want to say a very big thank you for engaging with the valuable content that I put out on this space. If this channel has educated you in any profitable way, I'd like you to do me a favor by subscribing, liking this video, and turning on the notification bell icon so when more videos like this come out, you'll be the first to be notified about it. Until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. Till I come your way the next time, thank you.